We're on P6, which is rational expressions. So rational expressions means that we have a fractional expression. We have an expression on top for the numerator and the expression on the bottom for denominator. And we are going to simplify by factoring and then canceling out any common factors that are in both the numerator and the denominator. So let's see what we can do. So I kind of expressed this. The only thing that we have to do is we have to exclude any values in the denominator that would make the denominator equal to 0. So we cannot have a 0 factor in the denominator. Because we've learned a long time ago that anytime you have a number over 0, that gives us an undefined answer. So we've got to find out what would make the denominator equal to 0, and then we would exclude that by saying x does not equal a certain number. Exclude values of x. And so we would write that as like x does not equal 2 or whatever it is. X does not equal a certain number that would make that denominator equal to 0. Okay, so let's look at our first example. To determine the numbers that must be excluded from the domain, examine the denominator. Factor the denomination and the denominator, and then set each factor equal to 0 to find the excluded values. So what we need to do is look at how we can factor this. So remember your product of negative 14, that gives you a sum of negative 5.
7 and 2.
7 and 2. Which one's negative though?
2. 7.
It would have to be 7 because this is negative 5. Because if we add these together, we'd get a negative 5. If the 2 was negative, that'd be a positive 5. But we know it's a negative 5. So this is 7x. And then this is x minus 7, x plus 2. And the reason we can just write it like that is because the coefficient of our leading term is 1. So we would look and see what would make this equal to 0. So we would say x minus 7 equals 0, x minus 2 equals 0. And these are the values that we will exclude.
So x equals 7, x equals 2.
Right, x equals 7, x equals 2. So those are the numbers that we'll be excluding. So I'm going to say x cannot equal 7 or 2.
But would it not be x plus 2?
That'd be a...
So it'd be
Oh, yeah. And then that'd be a negative 2. Thank you. Yeah, I wrote it wrong.
Sorry, I really didn't have any
no freshman year.
All right, let's keep on going. Yes, I can go back. All right, so all we wanted to do was write what values of the domain that we are excluding. So all we're doing is saying x cannot equal 7 and x cannot equal negative 2. Because if either one of those are plugged in, if I plug in 7 here, 7 minus 7 is 0. 0 times anything is 0. 7x over 0 is undefined, so that's why it can't happen. All right, in order to simplify a rational expression, we are going to factor and then cross cancel or cancel what's on the numerator denominator because that equals 1. And then write anything that's been excluded. All right, so if we look at this one, we need to factor x squared minus 1. So I recognize that x squared is perfect square, and negative 1 is also a perfect square. This is difference of squares. When you do difference of squares, it equals x minus 1 times x plus 1. Remember that middle term will cancel out, so all we have are perfect squares here. Okay, and then the next one, we can do our what multiplies to get 1 and adds to get 2. 1, yeah. So this is x plus 1, x plus 1.
Isn't the bottom line equal to 2?
I can't hear you.
Isn't the bottom line equal to 2?
Yeah, it's like you would do this x plus 1 squared.
Yes.
Yeah. And I expanded it out because I'm looking for common factors that I can cross out. Because it x plus 1 over x plus 1, because this is all multiplication, that equals 1. So it just leaves us with x minus 1 times x plus 1. Which I would just take out the parentheses altogether. It's just x minus 1 over x plus 1. And there's nothing more I can do with that. But we do need to write out what's excluded from the domain. So we would look back up here to find out what's excluded. So it's x plus 1 equals 0. So x cannot equal negative 1. Even though this one was canceled out, they're actually the same thing. So I only need to write x does not equal negative 1.
So we only exclude like what's on the denominator?
Yes, we only exclude what's on the denominator. And later you'll see that these are your vertical asymptotes. We're going to get into that later. But you can't go through negative 1 on the x-axis. So it's an asymptote. All right, let's look at the instructions. If you need to remember. Whenever you multiply rational numbers, you're going to factor the numerators denominators completely. Divide the numerators denominators by common factors. You're going to do the simplifying, cross out common factors. From numerator and denominator. And then the last thing is to multiply the remaining factors in the numerators and multiply remaining factors in the denominators. And then our last thing would be to write the excluded values from the domain. Values from the domain. All right, so let's look at the first one that we have here. So we can't do anything with x plus 3. So we're going to factor this x squared minus x minus 6. So x squared minus x minus 6. So what gives me a product of negative 6 and a sum of negative 1? 3 and 2. The bigger number is going to be negative because our sum is negative. So this is x minus 3 times x plus 2. Oh, and we still have this x plus 3. Oh, like that equal sign there. Okay, and then we need to do x squared minus 4. So this is that difference of squares. So x minus 2 times x plus 2. And then the next one is x squared plus 6x plus 9. So it gives you a product of 9 and a sum of 6. Yeah. And I'm going to write them both out. Okay, so just given this, let's go ahead and write what's being excluded before we start canceling. So what can x not equal from here? What's going to make x?
2.
Yeah. So 2 minus 2 is 0, so it's 2, comma. What about this x plus 2? Yep, negative 2 and negative 3. Now we can look for our common factors. So let's see. Is x plus 3 on top? Sure is. And then x minus 3, there's none. X plus 2, there is. Okay, now go to the next slide, which is right here. And that's what we have left. X minus 3, and then x minus 2 times x plus 3. Because we've canceled out everything except for x minus 3 on top, x minus 2 times x plus 3. So our last step would be, we don't want to leave it in this form. We want to go ahead and multiply.
Hey,
Yes.
On the excluded, is it -2 or -3? I mean, or +3.
What would make this equal to 0?
-3.
-3.
But then on the top it was -.
Or only look on denominator for exclusions.
Oh, so even if you mark it out, you put it.
Yes, even when you mark it out, you put it down. Yep. Because it's still a factor. Because even if you have a 0 on top and a 0 on bottom, that's not going to equal 1. That's going to equal undefined. That's one. Good question. All right, so then we would just do x minus 3 on top, and then go ahead and multiply this. So you can do FOIL or the box. And then I also want to go ahead and write, again, what's being excluded. So this is our full answer. This is the simplified answer, and then these are the excluded values for the domain. Okay, do y'all remember dividing fractions? Do y'all remember what you do whenever you divide fractions? No, what I'm really saying is like 4/5 divided by 2/3. Keep, change, flip, exactly. So instead you're going to write 4/5 times 3/2. Keep, flip, change. Yeah. Whatever you want to do.
And just kidding.
Which way? Up?
Yes.
Yes. So we find the quotient of two rational expressions by inverting the divisor and multiplying. Easier said, keep, change, flip. Anytime you divide fractions, you keep, change, flip. I think y'all learned that back in what, 6th grade? So now we're applying it to a harder concept with rational expressions. So we are going to keep this, change division to multiplication, and then flip the other fraction. So we can go ahead and write that. X squared minus 2x plus 1 over x cubed plus x times 3x squared plus 3 over x squared plus x minus 2. So now we need to factor and see if we can cross out any common factors. So x squared minus 2x plus 1. What gives you a product of 1 and a sum of negative 2? Negative 1. So x minus 1 times x minus 1. Over. What can I factor of x cubed plus x? X. So what's left?
X squared.
Say what? They are, but it's not a difference of perfect squares. It's the sum. So we can't actually do anything there. Okay, now let's factor out this. What can we factor out of 3x squared and 3? And what's left? 4 plus 1. Oh, that's good, right? Because we have a common factor. Let's wait, though. Okay, what gives us a product of negative 2 and a sum of 1? What'd you say?
2 and negative
2 and negative 1. So if I multiply these, I get negative 2. If I add these, I get positive 1. Very good. Pre-cal helping you out there? All right, so now we can simplify by finding our common factors that are in numerator and denominator. So this x squared plus 1, those are common. And then x minus 1. So on top, let's go ahead and put the number out front. So it's going to be 3 parentheses x minus 1. And then on the bottom, we have x plus 2. Oh, I forgot to write what we can't have. We'll come back to that. Our exclusions. And then we need to go ahead and multiply these. So we'll do some distributing. Okay, so let's look back at this one before we cancel. And let's look, we have an x, so what can this x not equal? No, right here, this lonely x. It can't equal 0. This one, if I square something, will it ever equal a negative 1? No. So I don't need to exclude anything from there. But this one, x plus 2. So what would go here? -2 plus 2 gives me 0. So that's a -2. And then here, 1 minus 1 gives me a 0. So x can't equal 1. Do y'all have any questions right now? Okay, now we are going to add and subtract rational expressions that have the same denominator. So whenever you have fractions that have a common denominator, you are going to add and subtract the numerators and then place it over the common denominator and simplify if possible. And then find if there are any excluded values. On this problem, we have a common denominator already. So all we're going to have to do is x minus this whole thing. So a common mistake here is to just do minus 3x plus 2. But what it really is minus the 3x plus 2, the whole thing, over our denominator.
So we have to distribute the negative.
Right, you have to distribute that negative. So you have to change the sign of everything inside here. So this is x minus 3x minus 2 over x plus 1. So I would find my like terms. So it'd give me a negative 2x minus 2 over x plus 1. Right, we can simplify this, factor out a negative 2 here. So it's actually negative 2 parentheses x plus 1 over x plus 1. I'll put it in parentheses. So if you can factor it, you always want to factor it and then simplify. Now we see that we can simplify those. So our solution is negative 2.
Should we have exclusions?
Yeah, we still have exclusions. So what can x not equal? Negative 1. So our solution to our difference problem here is negative 2, where x cannot equal negative 1.
It can be 0.
So if I were to plug in 0, I have 0 plus 1, which is 1. So that's okay. Okay, the next part is where we don't have common denominators in our fractions. So we'll have to find our common denominators and then follow the steps of adding or subtracting. So we'll find our least common denominator. So let's go on down. Here are the instructions. So go ahead and read those to yourself. Okay, let's look at example 10. Okay, and there's really not enough room to do anything here. So actually slide 17 gives us more room. So let's just look at the steps. Find the least common denominator. So first thing I need to do is I need to factor the denominator here. So what gives us a product of 25 and a sum of negative 10?
Negative 5, negative 5.
Yep, so x minus 5 times x minus 5. I'm just going to put these in parentheses like that. Okay, can I factor this right here?
You just do x minus 5 squared.
Say that again.
You just do x minus 5 squared.
It's not squared, it'd be 2x minus 5. Because we can factor out a 2. Oh, you're saying here? No, let's leave it separated. Expand it out. Okay, so let's see what our common denominator can be. So on this side, we have an x minus 5 times x minus 5. Over here, we have a 2 times x minus 5. What could we multiply this side by so we could have the same denominator? Yeah, a 2. So our common denominator is going to be 2x minus 5 times x minus 5, or x minus 5 squared. So then what do we need to multiply the right side by? Yeah, x minus 5. Okay, so the top here would be 2x, and then minus, I'm going to put this in parentheses, because we're going to subtract this whole thing. But what I want to do is I want to go ahead and multiply this out. X minus 4 times x minus 5. If you need to do the box, you can. So whenever I do that, I get x squared minus 9x plus 20. Okay. Over. Why don't we go ahead and write it with the x minus 5 squared, like that. And we can always expand it out later. All right, I need to simplify the numerator now. So I have this minus here. So I really need to change the sign of everything inside. So I'm going to change this and then change all the signs like that. And then I'm going to write it in descending order. So this negative x squared is first. Then I have 2x plus 9x, 11x, and then minus 20. And then I have 2x minus 5 squared. Okay, I need to see if this can be factored out at all. What do y'all think? This is actually prime. We could factor out a negative out there. Say that again. Oh yeah, we added the 2x and the 9x. Yeah, this is actually prime. Even if I did negative x squared minus 11x plus 20, there's nothing that multiplies to get, I just want to see how it changes the sign of everything. There's nothing that multiplies to get 20 and adds to get negative 11. So we can't do anything there. I'm not sure how Pearson's going to ask for it. They might ask you to go ahead and multiply this out. I'm not sure. Just if it gives you wrong, if it says it's the wrong answer, or it says it's correct, just not in the right form, you might need to multiply that out. So we do have some exclusions. What can x not equal? Or we only have one exclusion, actually. Yeah, x just can't equal 5. Because if we look back up here, or even right here.
So we have an assignment on this one?
Yes. All right. We are not doing any complex fractions. And let's look at. We don't want to do that one. So why don't I just have y'all do the assignment in Pearson?
Can I use the restroom?